Okay, all of you, very good morning. In this class, we have to discuss some of the exercise problems or example problems on the Lagrange's mean value theorem. So now we have to discuss one of the important example. What is that? See, uh, is it appearing to you, the whiteboard?
Yes,
Yes,
sir.
sir.
Yeah, see it. Yeah. Write an example. All of you note it. Show that v minus u by 1 plus v square strictly less than tan inverse of v minus tan inverse of u, which is strictly less than v minus u by 1 plus v square if 0 strictly less than u strictly less than v, and also reduce that the inequality pi by 4 strictly less than pi by 4 plus 3 by 25 strictly less than tan inverse of 4 by 3 strictly less than pi by 4 plus 1 by 6. It is looking
Sir?
like a very
Sir?
lengthy. Tell me.
So v minus u by 1 plus v square is less than tan inverse u minus tan inverse u less than same, sir. V minus u
Same,
by
sir.
1
How
plus
it
u.
can be
Yeah,
possible,
This
sir?
square.
yeah. You are right.
Yes.
This is u square.
Okay, sir.
Okay,
Yeah.
sir.
Thank you. Now see this one. Proof.
So we use y equals to tan inverse of x,
Yes,
right?
sir. Yeah. Exactly.
Okay,
Now,
so I think that's
yeah. Now, see, my dear students, here there is a one of the hint. What is the hint? Here, what is in the middle of this inequation? Tan inverse v minus tan inverse u. So here the hint is we have to take the function f equals to tan inverse of x. So this is the our required important hint. That's why first take a function f of x equals to tan inverse of x, and here we have to x and the interval here u comma v. This is first we have to take this one, and also we consider the function f. The function f is the condition 1 is continuous on the closed interval u comma v, and the condition 2 is differentiable on the open interval u comma v. So this is our consideration. What is that? First we have to take f of x equals to tan inverse of x and the interval u comma v. We consider, why we have to consider here? Consider the function f is the condition 1 is continuous on closed interval u comma v, and the second one differentiable on open interval u comma v. Why we have to consider? Suppose for example, if you take any interval, it may not be possible. Why? Because suppose for example, if you take take one value x equals to pi by 2. Suppose this pi by 2 is in middle of the u comma v. Suppose this pi by 2 is between u comma v at the time in the some functions. Here tan inverse is there. In case if you take tan inverse tan, suppose tan example, for example, some function g equals to tan pi by 4 equals tan pi by 2 equals to infinity. In this case, this function tan is not defined at pi by 2. Why? Because tan pi by 2 equals to infinity. Suppose similarly, here the differentiation, here the given function is f equals to tan inverse of x. What is the derivative of tan inverse of x? F dash equals to 1 by 1 plus x square. So here this tan inverse is always differentiable and also continuous. So here this is not a problem, but in some problems, maybe the given function may not be defined in all the intervals. That's why we have to take the function is continuous on closed interval a u comma v and differentiable on open interval u comma v. Why? Because here the given function is tan inverse of x. Tan inverse of x is always tan inverse of x is defined and continuous. So don't worry here. So here when it satisfies these two conditions by the Lagrange's mean value theorem, by the Lagrange's mean value theorem, there exists one point C belongs to open interval u comma v such that f dash of C equals to f of u minus f of v by u minus v. This is the Lagrange's mean value theorem. Instead of a and b, we substituted u and v. Yeah, this is the Lagrange's mean value theorem. F dash, already you know here f equals to tan.
It should be f of v minus f of u, no sir?
Yeah, f of v minus f of u.
Minus u.
This is v minus u. Yeah, f equals to tan inverse of x. Then the derivative of f dash equals to 1 by 1 plus x square. So here we have to substitute that one, f dash of x. This is f dash of c means 1 by 1 plus c square. This is so according these values we have to substitute in this function. So f dash of c means 1 by 1 plus c square, that equals to f of v. F of v means tan inverse of v minus f of u means tan inverse of u by v minus u. Okay, leave it. Now come to the next page. Students, are you understand up to here? Yeah.
Yes,
Now,
sir.
yeah.
Yes, sir.
Very good. Now come to the next point. I will go to the next page. This is f of v. This is f of u. This is v minus u. Now I will go to the next. I will go to the next page. See, my dear students, where is C here? C is between u and v. C belongs to u comma v. C belongs to u comma v means C is between u and v. This is the meaning of this one. So now I will use this one such that here.
Excuse me, sir.
Tell me.
Sir, like you have written this, so we have to write it in our notebook, or you'll provide these sheets in the WhatsApp.
Once again, you will check in our module. Everything is available.
Okay, sir.
Yeah. Now see the next one. Here the C belongs to open interval u comma v. The C belongs to open interval u comma v means u is strictly less than C is strictly less than v. Now I have to square on both sides. If you square on both sides, you will get u square less than C square less than v square. Then this can I have to add plus to the each term. Therefore, then you will get 1 plus u square less than 1 plus c square less than 1 plus v square. If you reciprocal all the terms, then the less than symbol should be changed into greater than. If you take reciprocal on both sides, the less than symbol should be reverse, greater than 1 by 1 plus c square, which is greater than 1 by 1 plus v square. Why? Because if you take the reciprocal, the symbol should be changed. That implies here 1 by 1 plus u square greater than, already this value, already you calculated this value. In the last page, already we calculated this value. See here, 1 by 1 plus c square equals to tan inverse v minus tan inverse u by v minus u. I will substitute this value at that respective place. Then if you substitute that value here, you will get tan inverse of v minus tan inverse of u by v minus u, which is greater than 1 plus v square. But already you know here u is less than v. Why? Because this is the interval u comma v means u is less than v. Then this u goes to that side, 0 less than v minus u. That means this is the positive value. If you multiply each term by a positive value, the symbol will not change. If you multiply every term with a positive value, the symbol will not change. That's why now I want to multiply these three terms by v minus u. If you multiply with v minus u, you will get v minus u by 1 plus u square, which is greater than v minus u into tan inverse of v minus tan inverse of u by v minus u, which is greater than v minus u by 1 plus v square. So here these two terms will be cancelled. This term and this term, these two terms will be cancelled. Then finally you will get v minus u by 1 plus u square, which is greater than tan inverse of v minus tan inverse of u by, sorry, no need to write here. Why? Because the term cancelled already. Therefore, v minus u by 1 plus v square. If you write in the reverse order, reverse order means v minus u by 1 plus v square, which is less than tan inverse of v minus tan inverse of u, which is less than v minus u by 1 plus u square. This is our required answer. Okay, now by using this answer, we have to prove one more condition. What is that? Pi by 4 plus 3 by 25, which is less than tan inverse pi by 3 less than pi by 4 plus 1 by 6. Now we have to prove this one. In this one, I will give the one of the hint. What is that? All of you understand this hint. Here pi by 4. Now we require the pi by 4, and also inside the tan we require the 4 by 3. Keep these 2 points here. Already I told the 2 hints. In the middle of the first inequation, there is a tan inverse v minus tan inverse of u. That's why we have to take the function f of x equals to tan inverse of x. That is the first hint. See the second hint. What is the second hint? Inside the tan, inside the tan inverse, there is a 4 by 3. Therefore, we have to take v equals to 4 by 3 here. And here the pi by 4, one angle pi by 4 is there. So how we can get the pi by 4? Tan 1 value is tan inverse of 1, or tan pi by 4 value equals to 1. Tan pi by 4. What is the tan pi by 4 value?
1.
Yeah, that's why we have to use the 2 hints. So I will apply the 2 hints here. What are that? See, here I am taking v equals to 4 by 3 and u equals to tan pi by 4. Tan pi by 4 value is equals to 1. Therefore, here I am applying these 2 values in the equation 1. Suppose, for example, this is the equation 1. In this equation 1, I have to apply the 2 values. What are the 2 values? U equals to 1 and v equals to 4 by 3. See this one, v minus u by 1 plus v square. V minus, already I told to you, v minus from 1, from the equation 1, from the equation 1 we can write v means 4 by 3, v minus u means 1 by 1 plus, here 1 plus v square means 4 by 3 whole square, which is less than tan inverse of v means 4 by 3 minus tan inverse of 1, u value is 1, which is less than which is less than v minus u. That means 4 by 3 minus 1 by 1 plus u square. U square means 1. 1 plus u square. U square means u equals to 1. This is, see all of you observe this one. This is our equation, equation 1. In this equation I substituted v equals to 4 by 3 and u equals to 1. Now we have to simplify this one. If you simplify this one by using the LCM process, here you will get, this is the by 1. Just use the cross multiplication. Here also by 1. This is also just fill by 1. Then you have to use the cross multiplication. You will get answer the 4 minus 3 by 3. 4 by 3. 4 minus 3 by 3, that equals to 4 by 3. Whole by 4 4 is 16 by 3 3 is 9. So 9 plus 16, 25 by 9, which is less than tan inverse of 4 by 3 minus tan inverse 1. Tan inverse 1 can be written as tan pi by 4. 1 means at the place of 1 we can write tan pi by 4, which is less than, here if you simplify this one, 4, if you use the cross multiplication, you will get the 4 minus 3 means 1 by 3 whole by 2. So
Sir,
if
in
you,
the left side also, 4 by 3 minus
by
1 is 1 by
1
3.
by 3.
yes, thank you. 1 by 3, not 4 by 3. Yes, you are right. Yeah, so here the fraction in the denominator, it should be reciprocal. If it is reciprocal, you can write 1 by 3 into 9 by 25, which is less than tan inverse of 4 by 3 minus tan and tan inverse. Simply we will call, both are cancelled. Then we can write pi by 4 here, which is less than, here 1 by 3. This can be written as simply whole by 1, which is the fraction. If it is reciprocal, then you will get 1 by 2. So then this can be written as 3 1s are 3 3s are, that's why 3 by 25, which is less than tan inverse of 4 by 3 minus pi by 4, which is less than 1 by 6. So this one we can write, if we add pi by 4 on each side, if you add pi by 4 on each side, you will get pi by 4 plus 3 by 25. Now we can add the pi by 4 to the each term, then which is less than, here the pi by 5, pi by 4 both are cancelled. Then you will get only tan inverse of 4 by 3, which is less than pi by 4 plus 1 by 6, which is our required final answer. Okay, see my dear students, anyone have any doubt in this problem at any step, once again I will explain. Okay, once I will show the first page. Yeah, this is our problem. Yeah, another form of Lagrange's mean value theorem. Another form of Lagrange's mean value theorem. What is this another form of Lagrange's mean value theorem? Suppose for example, f is, if f is a function defined on f is a function defined on closed interval a comma some a plus h, some a comma a plus h, such that the point number one, f is continuous on closed interval a comma a plus h. The second one, f is differentiable on open interval a comma a plus h. Then according to the Lagrange's mean value theorem, then there exists a point C belongs to open interval a comma a plus h, such that f dash of a, here c belongs to a comma a plus h, but here in this another form, I will once again, I'm telling you, all of you concentrate here what I'm telling. There exists c belongs to between a and a plus h. So instead of this c, here there exists one more element. What is that? Theta belongs to 0 comma 1. This is the very important. That's why I'm telling. So there exists a point theta belongs to 0 comma 1. Theta belongs to open interval 0 comma 1 such that f of a plus theta h equals to f of a plus h minus f of a by a plus h minus a. A plus h minus a, that means a cancel, then simply this can be written as simply h. So this is the another form of the Lagrange's mean value theorem. So now we have to use this form also to solve the sum of the problems. Now we have to write one of the example on this statement. Once again, I am telling you, f is a function defined on closed interval. F is a function defined on the closed interval a comma a plus h, such that one f is continuous on closed interval a comma a plus h, and f is differentiable on open interval a comma a plus h. Then there exists a point theta belongs to 0 comma 1 such that f dash of a plus theta h equals to f of a plus h minus f of a by h. So this is the another form of the Lagrange's theorem. Now we have to solve the sum of the problems on this one. See the example. So here use the mean value theorem. Use the mean value theorem. Use the mean value theorem to prove x by 1 plus x square, which is less than tan inverse of x, which is less than x, if x is positive, x is greater than 0. This is the problem. Already I told to you what is the hint here. So what is in the middle of the given inequation? In this middle of the inequation, already you know tan inverse of x is there. The derivative of the tan inverse of x is equals to 1 by 1 plus x square, 1 by 1 plus x square. So 1 by 1 plus x square already in this denominator. You can see in the denominator 1 plus x square is there, or 1 by 1 plus x square is here. That means tan inverse differentiation is 1 by 1 plus x square. This is the one side of this inequation. That's why here we have to apply the mean value theorem or Lagrange's mean value theorem. Now we have to start the solution. The given take the function. Take the function. Students, what is the function f here?
Tan inverse x.
Yes, very good. F of x equals to tan inverse of x. And also here our equation is in terms of only in x. Keep this point. In the last problem, once again I will show you. In the last problem, our required inequation only in terms of u and v. See this one. Here in this inequation, our inequation only in terms of u and v. But in the given problem here the problem is only in terms of x. That's why what is the interval here? Therefore, here we have to take the interval, and the interval is 0 comma x. This is the very important to you. That's why I am discussing this problem. Here the interval is only 0 comma x. Why? Because they didn't given the interval a comma b or u comma b. That's why here we have to take only 0 comma x. When we will take the interval 0 comma x, in case the given inequation only in terms of x, then we have to take the interval 0 comma x. Therefore, clearly you know that the first condition, f is continuous on closed interval 0 comma x. Why? Because the tan inverse of x is continuous on the interval. It is clear already, you know, everyone known it already. We discussed in intermediate. And also f is differentiable. f is differentiable on open interval 0 comma x. X is here the tan inverse of x is not differentiable in the closed interval. In the closed interval, this tan inverse of x is differentiable only on the open interval. Why? Because suppose, for example, what is the derivative of tan inverse of x is 1 by 1 plus x square. Oh, okay, even it is differentiable on closed interval also. So how to test it is differentiable or not? Suppose, for example, f dash, f equals to tan inverse of x, f dash equals to 1 by 1 plus x square. If you substitute any value between 0 to x in this function, you will get some particular value. Therefore, it is differentiable. Therefore, f is differentiable on open interval 0 comma x, and also differentiable on closed interval also it is differentiable. Therefore, here the condition 1, f is differentiable, and condition 2 is f is condition 1 is f is continuous on closed interval 0 comma x, and f is differentiable on closed open interval 0 comma x. So if these two conditions are satisfied according to the previous according to the above expression of the Lagrange's mean value theorem, we can write there exists theta belongs to 0 comma 1. There exists theta belongs to 0 comma 1 such that f dash of a plus theta h equals to f of a plus h minus f of a by h. So now we can use this inequation. Therefore, by Lagrange's mean value theorem, therefore by Lagrange's mean value theorem, there exists theta belongs to 0 comma 1 such that f dash of a plus theta h, which is equals to f of a plus h minus f of a by h. This is our problem. But in this problem already you know, what is x. Here a comma a plus h, this is our interval. But what is a equals to 0.
0.
Yes, a plus h means
0 plus h.
yes, 0 plus h. 0 plus h equals to x. What is our given interval? 0 comma x. Yes or no? Our interval is 0 comma x. That means a equals to 0 and a plus h equals to x. Therefore, h equals to x. Why? Because a equals to 0. Am I right?
Yes, sir.
Therefore, f dash. What is f? Already you know. F means tan. Once again, I will write f means tan inverse of x. Therefore, f dash equals to 1 by 1 plus x square. But here, f dash equals to 1 by 1 plus x square. So, f dash of a plus theta h. A plus theta h means 1 by 1 plus theta h, a plus theta h whole square. A plus theta h. A plus theta h means, what is a plus theta h? Already I told all the terms to you. What is that? 1 by a means 0, theta means theta, h means x, that equals to whole square. Simply this can be written as 1 by theta square x square. Once again I am telling you, here all of you understand the given interval is here in the definition, in the Lagrange's mean value theorem, the interval is a comma a plus h. But here we are taking the interval 0 comma x. If you compare these two, a equals to 0 and a plus h equals to x. Therefore, a value is 0, then h equals to x. But what is f? F equals to tan x. Derivative of tan x is 1 by 1 plus x square. Therefore, f dash of, we required f dash of a plus theta h. So, 1 by a plus theta h. X means 1 by 1 plus x square. At the place of x square, we have to substitute a plus theta x h whole square. So a equals to 0 and theta h means x. So substitute this value, you will get finally 1 by 1 plus 1 by theta x whole square. Substitute that value here. 1 by theta x whole square. That equals to f. F means tan inverse of a means 0 plus h means x minus a means tan inverse of 0 by
So sir, 1 by 1 plus theta x whole square, no sir?
1 plus 1 plus,
theta x whole square.
yeah, 1 plus. Here there is a 1 plus, am I right?
Yes, sir.
Yeah, 1 plus. Very good. Very good. Thank you. Yeah, this is. Therefore, this can be written as 1 by 1 plus theta square x square. That equals to tan inverse of x. Tan inverse of x. Tan inverse, this can be written as tan inverse of 0. 0 means we can write tan 0. Tan 0 is also 0. Yes or no? Yeah, therefore, here tan inverse and tan both are cancelled. Tan inverse tan both are cancelled. Finally, there is a x. This can be written as 1 by 1 plus theta square x square, which is equals to tan inverse of x by x. This is the equation 1. Or we can multiply with x. X is the positive. In the problem they given x is the positive. So if x is the positive, if you multiply with x on each side, then you can get 1 by 1 plus theta square x square, which is equals to x cancel here, then you will get a tan inverse of x. This is the equation 2. So here we got this one. Anyone have any doubt up to here? Anyone have any doubt up to equation 2?
No, sir.
Yeah. Now I will go to the
No,
next
sir.
one. Yeah. Thank you. Now I will go to the next one. Yeah. So now you can see what is given. Theta belongs to between 0 comma 1. That means 0 less than theta less than 1. This is the meaning of that theta belongs to 0 comma 1. Yeah. Now come to the next one. Now here x is positive. If x is positive, you can multiply with x, then the symbol will not be changed. Therefore, theta into x, 0 into x 0, and theta into x, theta x, which is less than 1. Why? Because less than x. Here x is positive, that's why we can multiply each term by x. The symbol will not be changed. Now I want square on both sides. If you square on both sides, what happened? If you square on both sides, what will happen?
Nothing, sir. Sign will be same.
Yeah, the symbol cannot be changed. That is the one thing. Therefore, this can be written as, if you square on both sides, 0 square means 0, which is less than theta square x square, which is less than x square. So now I want to add 1 on each side. 0 means 0, just 1 plus 0, which is less than 1 plus theta square x square, which is less than 1 plus x square. But in the equation 2, 1 plus theta square x square, it is in the denominator. That's why we have to reciprocal. Already I told to you, if you reciprocal the each term, then the symbol should be changed. So that's why if you reciprocal, 0 plus 1 means 1, 1 by 1, 1, which is greater than 1 by 1 plus theta square x square, which is greater than 1 by 1 plus x square. Why? Because if you take reciprocal, then the symbol, the less than symbol should be converted into greater than. Therefore, this is the one of the equation. Or this can be simply, we can write, now x is positive. If x is positive, we can multiply each term by x, the symbol will not be changed. So x into 1 is x, which is greater than x by 1 plus theta square x square, which is greater than x by 1 plus x square. So simply, if you reverse the order, then you will get x by 1 plus x square, x by 1 plus x square, which is less than x by 1 plus theta square x square, which is less than x. I think this is our required answer. Am I right? Students, are you understand this one?
Yes, sir.
Yeah. Is there any doubts? Please tell me. Then we can discuss the doubts.